So for our next problem, we're going to do a problem that's a little bit more complicated but fairly similar. It's just going to demonstrate a few more of the issues in solving these types of problems. So what we have is the problem to evaluate the integral of x squared plus 2 over the denominator is the product of x minus 1, 2x minus 8, and x plus 2. So we don't have to factor anything in the denominator. We're already given the product of three linear factors. So we just need to set this up in accordance with the rules. So what we know is that we put a constant over each linear factor. A x minus 1 plus b, let me actually change the color here, a over x minus 1 plus b over 2x minus 8 plus c over x plus 2, and that's equal to x squared plus 2 over x minus 1, 2x minus 8, x plus 2. So we've done is we've set up the decomposition. This is what I refer to as the setup of the decomposition. And by the way, let me just take this opportunity to demonstrate one fairly important thing. I will often see people write things like this: x minus 1, 2x minus 8, x plus 2 is equal to a over x minus 1 plus b over c over. This is not true. In other words, it's not true that the antiderivative of this rational function is equal to the sum of these three fractions. You really have to put the antiderivative, you have to use the antiderivatives or integral symbol consistently on both sides. I don't make a big deal about how people use symbols, but one thing that I think bothers everybody is when we see people sort of abuse the equal sign and write an expression where the thing on the left is they put an equal sign in between two things that are not actually equal to each other. So don't do that. Just understand what it is that you're doing. You're sort of extracting the fraction from the original integral, and that's the thing that you're setting to be equal to this decomposition here. So anyway, all right, let's go on and solve the problem with that. Having said that, so what we want to do is we want to do the same thing. We're going to multiply through by the big denominator, and that's going to leave us with a bunch of cancellations. So we get a times 2x minus 8 x plus 2 plus b x minus 1 x plus 2 plus c x minus 1 2x minus 8, and that's equal to x squared plus 2. If you're wondering how I get these factors left over and whether these are actually correct, please see the previous example where I go through why these are in fact the factors that remain when I multiply through by the denominator. So anyway, what we want to do is the same sort of technique. We want to zero out we want to zero out the factors in order to be able to isolate each constant. So I'll show you how that works. Let's let x equal 1, and this is, oh, actually, before I do that, there's one thing I just wanted to point out. This technique applies because this polynomial in the numerator has a lower degree than the denominator. What we can see is that the denominator, when I start multiplying, regardless of what the denominator comes out to, when I start multiplying, I'm going to get x times 2x times x, which is going to give me an x to the third. So we have on the bottom, we had degree 3, and on the top, we can easily see that we had degree 2. This is necessary in order to allow this technique to proceed. So it does apply here, but I just wanted to point out that that was, in fact, necessary. We had degree 2 over degree 3. So, all right, back to the solution. So we're going to let x equal 1, and we're going to substitute that into this big expression, this big equation that we have here. So that's going to give us, let's have a times 2 times 1 minus 8 is negative 6, and 1 plus 2 is 3. Then we have b. When I substitute in 1, I'm going to get 1 minus 1, which is 0, and 3. And with c, I'm going to get 1 minus 1 is also 0, and then negative 6. The important point here, of course, is that I got zeros in one of the factors next to b and c, so those are just going to drop out. Now on the right, I didn't have to do this in the last example, but on the right I do have an x, so I'm going to have to use it consistently. I have to rewrite this as 1 squared plus 2 is equal to 3. So that leaves me with a times negative 18 is equal to 3, which leaves us with a is negative 1/6. So that's one of our constants. Let's do the next one. So we have let x equal, we're going to let x equal 4 because that's going to zero this constant. So It's 2x minus 8. If I put in x equals 4, I just get 8 minus 8, which is 0. So this is now going to be a times 0 and 6 plus b. It's going to be 3 times 6 and plus c, which is from 3 times 0 is equal to 4 squared is 16 plus 2 is 18. So I have 18 on the right. So that gives me, what I'm left with is b times 18 equals 18, which gives us, very conveniently, b equals 1. And now finally, let's do the last one. Let's let x equal negative 2, because that's going to zero this constant. That's going to zero the x plus 2 term. So if I do that, I get a times, I know that since I have an x plus 2 term next to the a, it doesn't really matter what happens when I plug in negative 2 into the 2x minus 8, because the point is that I'm going to get 0 in the x plus 2 term. And same with the b term. And then with the c term, I've got negative 2 minus 1 is negative 3, and negative 2 times 2 is negative 4 minus 8 is negative 12. So, and that's going to equal negative 2 squared is 4 and 2 is 6. So that gives me 36c is equal to 6, or c equals 1/6. So there we go. So we have the integral. Actually, let me just bring this integral down. Where do I want to put this? Let's write it over here. There we go. So that integral is equal to the integral of negative 1/6 over x minus 1 plus 1 over 2x minus 8 plus 1/6 over x plus 2 dx. So what we can see is that we just have the integral. Sorry if you can't see this bracket here, but it is here. So that's what that should look like. That's going to be, let's write this a little bit neater. Integral sign, bracket. Sorry about the color change there. So what we have is we have an integral that's just going to be the sum of, it's the integral of the sum of 3 very simple fractions. So this is going to be 1/6 ln of x minus 1 plus, this is what many people are going to rewrite this and say, oh, I have 1 over 2x minus 8, so surely that's just equal to ln of 2x minus 8. And they would be wrong. If you do this by u substitution, you will see that because of this 2 that appears here, I actually have to write a factor of 1/2. You're welcome to actually do the whole thing by u substitution, or you can simply remember that the integral of dx over ax plus b is equal to 1 over a ln of ax plus b, and convince yourself by u substitution that that is true. So it's important to realize this. In fact, those of us who are teaching this class, we consider it to be an important goal that you understand that the integral of 1 over thing is not always ln of thing. It depends on the circumstances, so you really do want to work through that, and this is one of those circumstances where that is not true. So you do actually need that 1/2 there. And then plus 1/6 ln of x plus 2. This is actually a circumstance here where ln of the integral of 1 over x plus 2 actually is ln of x plus 2. So you just have to know when that's true and when it's not. And I invite you, as to this term, to integrate this by u substitution, and you will see why that 1/2 needs to appear. So here's the answer. As you can see, these problems are fairly long and tedious, but they're not, I wouldn't say that it's the most complicated thing that we've done. It's really just a lot of algebra and then applying some fairly simple integration rules.